Question 24 from Paper 1 of the 2022 Higher Physics exam from the SQA. Which row in the table describes the conduction band and the gap between the conduction band and the valence band in an insulator? Well, let's take a look at the band situation for an insulator. We can see in an insulator the valence band is completely filled up and the conduction band is unfilled, and there's a gap, a large gap in between the conduction band and the valence band. So what we're looking for in this table is we're looking for the conduction band to be unfilled, and it's going to be either that one or that one, and we're going to have a large gap between the valence band and the conduction band as seen on the diagram. So that'll be the large gap there. So our answer for this one is C. Question 25 from Paper 1 of the 2022 Higher Physics exam from the SQA. Astronomers use the following relationship to estimate the mass m of a galaxy. M equals v squared times r, all divided by g, g being universal gravitational constant, where v is the orbital speed of the star in the outer regions of a galaxy measured in meters per second, r is the orbital radius of the star measured in meters, and g is universal gravitational constant, which we can look up. The star orbits at a radius of 4 times 10 to the power 20 meters, so that's in the correct units, in the outer regions of the Triangulum galaxy. The orbital speed of the star is 120 kilometers per second, and we have to change that into meters per second. So based on this information, the mass of the Triangulum galaxy is giving you 5 possible responses. Okay, we start off with m, that's the equation. The mass of the galaxy is v squared r all over the universal gravitational constant. And we know that v is going to be equal to the speed of the star, and that's given us 120 kilometers per second, which we have to change into 120 times 10 to the power 3 meters per second to get the correct units. R, the radius which the star orbits at, is 4.0 times 10 to the power 20 meters. And we know the universal gravitational constant g is going to be equal to 6.67 times 10 to the minus 11. And we'll just leave the units out for that for the moment. So it's a simple case of plugging things into the equation. So m, the mass of the galaxy, is going to equal to v squared, 120, times 10 to the power 3, and we have to square that number, so you square that, multiplied by the radius, which is going to be 4 times 10 to the power 20. And we have to divide that all by the universal gravitational constant, 6.67 times 10 to the minus 11. So we do that with our calculator, we end up with the mass is going to equal to 8.63 times 10 to the power 40, and that will be in kilograms. We can round up to two significant figures to give us 8.6 times 10 to the power 40 kilograms. And that corresponds to the following answer for the last question. That's going to be answer E. Our final question, our final answer, answer E.